Hi everyone, welcome back to Infino. So let's move on to the next part. The next part is the variations of the cosine square and the sine square. So under some curriculums, especially under the American and the Canadian syllabus, they call it as the power reducing formulas, power reducing. These two formulas, they're quite useful because they're trying to link up the square on the left-hand side and the double angles formula on the right-hand side. So let's see how we can derive these two formulas. For the cosine square, we try to derive it from the cosine 2 theta, which is 2 cosine square theta minus 1. And then we try to put the cosine square as a subject, which is 2 cosine square theta equals cosine 2 theta plus 1. And that's why the cosine 2 theta is just simply 1/2 bracket 1 plus cosine 2 theta. And then for the sine square theta, just the same, we use another variation, which is the cosine 2 theta equals 1 minus 2 sine square theta. And that's why 2 sine square theta equals 1 minus cosine 2 theta. And that's why sine square theta is just simply 1/2 bracket 1 minus cosine 2 theta. Then should be too hard, pretty straightforward. So these two are the power reducing formulas. And then for the triple angles formula, the sine 3 theta, we try to derive it from the double angles formula, which is sine 3 theta is sine 2 theta plus theta. Then we use compound angle formula, which is sine 2 theta cosine theta plus cosine 2 theta sine theta. And then sine 2 theta is just simply 2 sine theta cosine theta times cosine theta. Cosine 2 theta, I try to use the previous version, which is the 1 minus 2 sine square times the sine theta. And here I combined it, which is 2 sine theta cosine square theta, and then plus 1 minus 2 sine square theta times sine theta. And then I use 2 sine theta cosine square, I change it to 1 minus sine square theta. And then here I expand it like sine theta minus 2 sine cube theta. Here as well, like expand it, which is 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. And that's why if I combined the like terms, then that will be 3 sine theta minus 4 sine cube theta. Done for the sine 3 theta. And then for the cosine 3 theta, just the same, if I use cosine 3 theta equals like cosine 2 theta plus theta, then compound angle formula, which is cosine 2 theta cosine theta, and then minus sine 2 theta sine theta. And then if you look at the form on the right-hand side, I only got cosine, and that's why I would try to use the previous variation of the cosine 2 cosine square theta minus 1. And then cosine theta minus this one is 2 sine theta cosine theta times sine theta. And that's why if I expand it, this one will be 2 cosine cube theta minus cosine theta minus, here, like, I got 2 and then sine square, right? Sine square, I can further change it to 1 minus cosine square because of this guy. And then here I got like 2 cosine cube theta minus cosine theta minus 2 cosine theta, negative, negative, positive 2 cosine cube theta. And that's why my final answer will have 4 cosine cube theta minus 3 cosine theta. So let us check the form, which is 4 cosine cube theta minus 3 cosine theta. 3 cosine theta. And then finally would be tangent 3 theta. Tangent 3 theta is basically just what? Is basically just the compound angle formula for the tangent, which is tangent 2 theta plus theta. Then here will be just tangent A plus tangent B over 1 minus tangent A tangent B. And then the next one is what? The next one is tangent 2 theta indeed is here, which is 2 tangent theta over 1 minus tangent square theta. 2 tangent theta over 1 minus tangent square theta. Here is plus tangent theta over 1 minus 2 tangent theta over 1 minus tangent square theta times tangent theta. Let me double check whether I missed out anything. Oh, I didn't, so that's correct. And that's why the final step is just to simplify it. Then how to simplify it shouldn't be too hard, because like here I got 2 tangent theta over 1 minus tangent square theta plus tangent theta over. So first of all, I can combine. Here is 2 tangent square theta over 1 minus tangent square theta. And then if you look at the form of the tangent 3 theta, the right-hand side, we got tangent cube. So basically, I want to eliminate the fraction within fraction. You can have 2 ways. The first way is to find a common denominator, or I try to use another method, which you can multiply both the numerator and denominator by 1 minus tangent square. So if you're doing this way, then you will have something like 2 tangent theta plus tangent theta bracket 1 minus tangent square, and then over, this is 1 minus tangent square theta minus 2 tangent square theta. So this method is pretty fast, right? So that's why it's 2 tangent theta plus tangent theta minus tangent cube theta over 1 minus 3 tangent square theta. And that's why the final answer will be just simply 3 tangent theta minus tangent cube theta over 1 minus 3 tangent square theta. Minus 3 tangent square theta. Is it okay? So this is how we derive the triple angles formula, which is the sine 3 theta, cosine 3 theta, and tangent 3 theta. So I hope you enjoyed the video, and if you want to learn more from this channel, please like our videos and subscribe to our channel, and I will see you next time. Bye bye.